This program is not science fiction. It is a report on science's very real search today for the existence of life on other worlds. A search by microscope examining the smallest particles of matter in nature, by telescope viewing the largest objects in space, a probe into distant galaxies and star clusters, looking with the enormous eyes of the optical telescopes, and listening with the electronic ears of the radio telescope for signals from outer space. And eventually this search will be carried on by man himself through interplanetary travel. The elements that exist here on Earth and the chemistry of our world are the same as on the most distant star. If the atom, one of the smallest particles of matter, and the galaxy, the largest mass in the visible universe, are governed by the same physical laws, then life might well have evolved from the hydrogen atom in space, continued to the development of the human brain, and may have repeated a similar process unnumbered times in the hundreds of billions of worlds abounding in the cosmos, making the probability great that intelligent creatures beside Earthman people the universe. On just the beginning of this search for life on other planets, the American taxpayer is spending $2 billion in probes of Mars alone. Nobel Prize-winning scientist Dr. Harold Urey says of the cost of the space program,
now some people say that we can't afford the space program. But I say the Greeks couldn't afford the Parthenon. And the Egyptians couldn't afford the pyramids. And Middle Ages couldn't afford the great cathedrals of Europe. You could have always spent this money, as they say, for something else. But you know, we can't afford this space program. If we could prove that life existed on Mars or ever did exist on Mars, in my opinion, it would be one of the most stupendous discoveries of this century.
Not Alone is brought to you by B.F. Goodrich, the name that spells quality in tires, chemicals, plastics, footwear, products for home, industry, and aviation. B.F. Goodrich.
Why is it tire buying day always seems like the morning after? All the waiting around, the endless confusion about the right tire to buy. And the biggest blow of all, the money it costs. Now, B.F. Goodrich doesn't give away free tires. But if tire buying day drags you down, we'll wake you up with a brand new way of doing business. No confusing tire talk, just straight talk. We've got nothing up our sleeves except this, a special tire value calculator that'll find you the right tire at the right price. The lowest price B.F. Goodrich tire for the way you drive. Well, you may be so happy at the money B.F. Goodrich can save you, you'll want to bring something home to your wife. B.F. Goodrich. The straight talk tire people.
your narrator, Edward P. Morgan.
The fixed stars in our firmament have, through the ages, given man a feeling of security. We have always wanted to believe that we have our feet firmly planted on a solid earth with a protective heaven above. But science has continually whittled away at this idea. For some time, we have known that our earth, in reality, is only a changing ball of rock and soil, water and air, held together by a tenuous gravity, spinning and whirling in space around our sun. And even as a planet, we are not very special, being only one of 9 in orbit around the mother sun. Our sun itself, a star and only a small middle-aged one as stars go, is a kind of lost child on the outskirts of its galaxy, which we can see in the sky as the Milky Way. It is only one of hundreds of billions of stars in our galaxy, which is only one of hundreds of billions of galaxies, all of which are in constant motion. If we are not unchanging in space, neither are we eternal in time. Our sun, 5 billion years old, will, in another 5 billion years or so, burn itself out, and in doing so expand and absorb all its planets as countless other stars have done before. Our sun's only real distinction that we know of thus far is that it has people whirling around it. The question is, might this have happened elsewhere in the universe, or are we alone? It was recently discovered that stars and gases in space emit natural radio waves which can be picked up and amplified by radio telescopes. The Jodrell Bank Radio Telescope in England, the Green Bank Radio Telescope in West Virginia, and this one at Arecibo in Puerto Rico can be called man's largest ears. The bowl of the telescope, 1,000 feet across, made of half-inch wire mesh, acts as a reflector, able to focus even extremely weak radio signals from space. In searching for life on other worlds, the theory is that intelligent civilizations in the universe would use natural radio frequencies as a means of communicating with one another. By listening to signals from interstellar space, intelligent codes could be distinguished from the patterns of natural radio waves. Radio astronomer of Cornell University and director of the Arecibo Ionospheric Observatory, Dr. Frank Drake, conducted Project Ozma, the first search for intelligent life in space by radio telescope.
Some years ago, it was suggested by Professors Morrison and Cacconi at Cornell that there might be other civilizations in space attempting to send us messages. We use very sensitive and ingenious detecting devices to search for intelligent signals amongst static which comes to us from the interstellar space. So in 1960, we made a short search for such signals with existing telescopes, such as the 85-foot telescope at Green Bank, using the 21-centimeter line frequency. And we looked at, there was time, in fact, to look at only 2 stars. The ones we picked, of course, were the 2 nearest stars, which are like the sun. The stars Tau Ceti in the constellation of Cetus the Whale, and Epsilon Eridani in the constellation of Eridanus. We found no evidence for extraterrestrial intelligence signals. But now we must realize that this was an extremely limited search, and the fact that we found nothing should not discourage us or cause us to think that any future search is going to fail. One can estimate that a search which has a good chance of succeeding will take perhaps 30 years. But if one is going to make a realistic search, this is what is required, and anything less than this is really not worth the effort because the chance of success is so small. Surely the results of the detection of extraterrestrial signals are going to be one of the most exciting things that ever happened.
While some scientists in the discipline of astronomy press the search for intelligent life in the distant stellar regions beyond our solar system with the big ears and eyes of the radio and optical telescopes, some, perhaps more down-to-earth investigators, feel they would be making an historic discovery by a less ambitious find. These men are called exobiologists. They are looking for microbiologic forms of life, lesser than intelligent man, and perhaps higher than the lowly virus, something between the organic molecule and the bacteria that might have evolved outside the Earth. The most likely candidates for such a search are the planets Mars and Venus, Earth's nearest neighbors in the solar system. The Mariner spacecraft has been our principal vehicle for unmanned planetary exploration. The planetary program is carried out by the Jet Propulsion Laboratory, operated by the California Institute of Technology, for the National Aeronautics and Space Administration. Dr. William H. Pickering is the director.
Mars and Venus, of course, are the two closest planets to the Earth. In some ways, we know more about Mars than we do about Venus, because Venus is always covered with clouds. We do not believe we have ever seen down to the surface of Venus, that is, with a telescope from the Earth. Whereas in the case of Mars, we usually see the surface of Mars. Mars, on the other hand, is a planet which astronomers for many years have compared with the Earth. The size is a little smaller than the Earth. It happens that the day on Mars is almost exactly the same length as the day on the Earth. The year is about twice as long as the year on the Earth. The seasons change in the same manner that they do on the Earth. In other words, the spin axis of Mars is tilted about the same way that the axis of the Earth is tilted. All of this has led astronomers to compare Mars with the Earth in many ways. And of course, the one comparison which one must always make is, what about life? Is Mars a suitable planet for life as we know it?
It is feasible, from what we know about life on Earth, that life could exist on Mars.
Dr. Richard S. Young, chief of the Exobiology Division of NASA's Ames Research Center.
Life on Earth probably arose as the result of a very natural sequence of events. We think we know what the primitive atmosphere of the Earth was like before there was any life on the Earth. We think we know what types of energies were available on the primitive Earth before there was any life on Earth. Biological evolution took over and the atmosphere was changed rather drastically until we have the sort of atmosphere we have on the Earth today, and we have the tremendous diversity of life that we have today. A subsequent result over the next, say, 3 billion years of biological evolution. In fact, then, just about any primitive planet during its early history should have undergone a similar sequence of events. They were formed obeying the same laws of physics and chemistry. They should have had the same type of primitive atmosphere and probably underwent chemical evolution in much the same way the Earth did. Now, what we need is proof of that.
If we can find life on one planet, say Mars, then it is very probable that elsewhere within our own galaxy there must certainly be planets comparable to Earth with life forms comparable to Earth.
The optical telescope has been the principal tool of astronomers for studying the stars and the planets from the days of Galileo centuries ago. The 200-inch mirror in the Palomar Observatory telescope in California can be called man's largest eye. It can bring into view the farthest observable objects in the universe, called quasars, points of light believed to be billions of light years away and moving away from us at incredible speeds. Another kind of telescope is the 26-inch refractor or direct view telescope, like this one at the United States Naval Observatory in Washington, D.C. To find planets comparable to Earth, revolving around stars comparable to our sun, Dr. Kai Strand, scientific director of the observatory, and his former colleague, Dr. Peter Van de Kamp of Swarthmore College, used a telescope of this type. They wanted to verify the argument that planets are abundant in the universe. In 1963, Van de Kamp announced the discovery of a planet orbiting a neighboring star, the first planet ever to be detected beyond our solar system, although it has never been directly seen.
Depends what you mean by seen.
Harvard astronomer Carl Sagan explains how the existence of this planet was deduced.
The second nearest star system after the Sun is called Barnard's star, named after an American astronomer, E.E. Barnard. And the motion of this star across the sky is not a more or less uniform line on the background stars, as you might expect, but instead oscillates. And the wiggly path is due to the presence of a dark companion. We don't see the dark companion, but we can quite reliably deduce its presence from the wiggles in the motion of this star. Let's suppose this is Jupiter and this is the Sun, and the two of them are moving across through space together. However, Jupiter is also going around the Sun. And when Jupiter is on this side of the Sun, its gravitational attraction pulls the Sun a little bit that way. When it's on the other side of the Sun, it pulls the Sun a little bit that way. And so, as the Sun goes through space, it has, in addition to its ordinary motion that way, it has, let's say, an up and down wiggle due to the motion of the invisible Jupiter. Okay? And so the wiggle tells you the presence of Jupiter. And not only that, it tells you its mass, and it tells you how far away it is.
If the existence of planetary systems around stars other than our own Sun is a scientifically established fact, and if, as we know, there are hundreds of billions of such suns in our own galaxy alone, some leading astronomers dedicated to the idea that life does exist elsewhere have calculated the possible number of stars whose energy might support life. Astronomer Dr. Harlow Shapley, Director Emeritus of Harvard College Observatory, who first measured the size of our galaxy, now retired to his New Hampshire farm, discusses cosmic matters with two young friends, Georgia and Emily Hubley.
How many stars are there?
In the sky, the whole sky, how many stars are there? Well, you can see 1,000 stars when you go out some clear, dark night, 1,000 stars. Naked eye stars, we call them. But if we put a telescope into action, we get deeper and deeper into space, and the further out we go, Emily, the more stars we find. And so now, how many stars are there? Well, I've measured these galaxies and these stars and these shooting stars and so forth. And you know what I find out? That there are just billions of these galaxies. Now, billion, you know what that billion is. It's 1,000 million. Well, there are more than 1,000 million of these galaxies in the sky, and each galaxy has more than 10,000 million stars. And so there's just lots of stars in the sky. I'll give you the number if you'll try to remember. The number of stars is more than 100,000 million billion. Stars enough for everybody. See, if you want some stars, you can have a lot of them. I don't know whether there's anybody living on those stars. Not on the stars. You can't live on the stars. The sun, you can't live on the sun.
Yeah.
Why?
It's fire.
Yes, it's too hot. That's it. Much too hot.
Mm-hmm.
But planets, yes, you can live on it. That is, here on this planet we can. You know of any other planet where we might find life?
No.
No? You ever hear of Mars? The planet Mars. That might have some life on it. It might have, and we'll have to get more and more observations, and then we'll come out. My guess is that there are more than 100 million planets that have living things on them. By living, I mean like trees and grass and people and that kind. I think at least that many. And I'm a very conservative person. Our galaxy is wheel-shaped, you know. It's flattened like this, but has a big center. And it has that 100,000 million stars scattered all the way through it. It's rotating, too. We've measured that. It's turning around. Long time in turning around? I'll tell you how long. It'll take about 200 million years to make one complete turn around in our galaxy from where we are. Any other questions?
How are the planets formed?
Oh, how are planets formed? Oh, that's a hard job. But I'll tell you, we think that once before, long ago, there's a whole lot of dust and gas in space, and it contracted, it came together, and it got hotter and hotter, it came together, and it left off some chunks that went whirling around, and those were the things that became planets. So we had the sun, you see, built out of a shrinking nebula, we call it. Out of that shrinking nebula is sun, and it threw off these particular little chunks, little compared with the sun, and those little chunks developed into being the planets. We have the Earth. Once was gaseous nebulosity, we call it. It once was gas, and it shrunk down, and now you see it's hard. See how hard it is.
We are not alone. We'll continue with science's search for life on Mars and the exploration of life's origin on Earth after this message from the B.F. Goodrich Company.
If you have little feet, big feet, bold feet, cold feet, casting feet, blasting feet, planting feet, romantic feet, splashing feet, B.F. Goodrich is always coming up with innovations in footwear. Innovations like the Posture Foundation wedge we build into the heels of sneakers to take the strain off foot and leg muscles. Innovations in cold weather boots, insulated to keep feet warm even at 25 below zero. Innovations to protect workmen's toes. And all kinds of fashion footwear we make just for the fun of it. Known for being pretty fast on its feet.
Here again, your narrator, Edward P. Morgan.
If you were riding the nose cone of a rocket to the moon, this is what you would see as you approached the lunar surface for a landing. These pictures were made by television cameras in Ranger 9, the unmanned American picture-taking expedition to the moon in March of 1965. Since then, thousands of spectacular close-up pictures of the moon surface have been returned by Surveyor 1, which soft landed on the moon in June of 1966. Pictures from the probe of Lunar Orbiter in August of 1966 showed our planet as seen from the vicinity of the moon. This representation of the lunar landscape shows us what a man might see from the moon. A bright sun in a sky black as night due to the lack of light diffusion by an atmosphere, and the Earth visible in the lunar night hanging in its black sky like an oversized moon itself. Surveyor 1 and Lunar Orbiter returned much valuable information, and they have also shown us what we have known the moon to be: a body without atmosphere, without water, without life. Not unlike the moon in some aspects is Earth's neighbor in the solar system, the planet Mars. When, in July of 1965, the Mariner 4 spacecraft completed a successful Mars flyby after a journey of 8 months and 325 million miles, passing within 6,500 miles of the planet, 21 pictures of the Martian surface were returned to Earth, including one of the most remarkable scientific photographs of this age, Mariner's 11th picture of Mars. Many scientists felt that this picture settled once and for all the century-long controversy over Martian canals. In 1877, the Italian astronomer Giovanni Schiaparelli claimed to have seen canals which he thought could be evidence for intelligent life on Mars. As late as 1908, the American astronomer Percival Lowell confirmed the sightings. The spacecraft Mariner was too far away in its flyby to be able to show decisively what exists on the Martian surface. But most scientists agree that if life does exist there, it will not be intelligent but of a very low order.
Of course, the early astronomers saw canals, and they saw a lot of other things that...
Dr. Richard Young of Ames Research Center.
We no longer think canals really exist on Mars. We think they're primarily optical illusions, and then aren't something that the Martians constructed to transport water from the pole to the equator and keep the deserts wet and all that sort of thing. Mars has, although it's a harsh environment by biological standards, Mars has an atmosphere. It has a very rare atmosphere. It's a smaller planet, has a lower gravitational field, and its atmosphere is probably something like 1/100th, or perhaps even closer to 1/1000th of the total pressure on the surface of the Earth. It also contains water. Life can't exist without water. So the fact that Mars has water is terribly significant. Now, unfortunately, from a biological point of view, the amount of water in the atmosphere of Mars is very slight. It's about 1/1000th of the amount that one would detect in the Earth's atmosphere with a similar observation. There are other features of Mars that we're reasonably familiar with. Astronomers have been observing it for something approaching 100 years now, and they've known that there are light areas and there are dark areas. The dark areas are assumed to be, or at least by the early astronomers, were assumed to be vegetation. The light areas were assumed to be deserts. There are also pole caps on Mars, which have been shown to be water. However, although they're pretty extensive, the total amount of water in these pole caps is very slight. It's probably nothing more than a layer of frost. However, these pole caps do recede seasonally. In the spring, the pole cap recedes. At the same time the pole cap is receding or disappearing, the dark areas are getting darker. Implying, at least to the early astronomers, that, well, water is becoming available now from the pole caps, and the vegetation in the dark areas is literally inhaling the water and is flourishing during the spring. We really simply don't know enough about the intimate detail of the surface of Mars to critically analyze any of these visual phenomena. All we can do is speculate about them. And so far, the best of our speculations has failed to demonstrate that life on Mars must be ruled out. In fact, the best of what we know still leaves well within the range of possibility the idea that life may well exist on Mars and would be well worth the search, if you will.
I feel that in the search for extraterrestrial life, there are three approaches. One, firstly, the one that you named, to go to Mars and see whether there's life there. The other one, which Frank Drake has for some time tried out, listening to radio communication from outer space. The third one is the one that we are working on here, retracing the path by which life appeared.
Dr. Cyril Panam-Peruma, chemist at Ames Research Center, is searching for answers to extraterrestrial life by studying the chemical evolution of life on Earth.
From the information we have today, we know that the Earth is 4.5 billion years old. Let me put that down as one of our starting points. 4.7 billion years is the exact given. Life as we know it, or the first evidence of life in the fossil record, is about 3 billion. Now, biology, or the Darwinian theory, takes over from here. To find the life evolving into a whole variety of organisms. We know that mammals are around 160 million, and then so on we come to the evolution of man, finally. What went on before this, from the time the Earth was formed? or even further back from the time the solar system was formed. This can be described as chemical evolution. We know that the solar system is about 5 billion. And then, if you go backwards in time, you come to the origin of the universe, which is greater than 10 billion. Some put it at 13, some at 20, but we know definitely it's more than 10 billion years. Now, we have some starting points to go on. We know that 90% of the universe is hydrogen. So the hydrogen then, by a series of reactions during the birth of a star, gave rise to the other elements of the periodic table: carbon, nitrogen, oxygen, and so on. In other words, you would have thermonuclear reactions taking place within a star. So the idea of chemical evolution then is the gradual evolution of hydrogen, the initial matter of the universe, to give the elements of the periodic table, to give the constituents of the early Earth atmosphere, say methane, ammonia, and water. Simple chemistry tells us that the carbon will be in the form of methane, the nitrogen will be in the form of ammonia, and the oxygen will be in the form of water. So the early atmosphere of a planet would have been made up of methane, ammonia, and water. From here on, we visualize what happened. The early atmosphere being acted upon by lightning, or ultraviolet light from the sun, or heat, producing organic molecules, till the early oceans became something like a primordial soup. So from a primitive atmosphere, we are hoping to go to the stage when the two molecules that are important to living things, the nucleic acid and the protein, were formed. First molecules capable of replication. So it's a stepwise process. There appears to be a beautiful plan going all the way from the hydrogen atom till the time you get to the intelligent human being. So it is a coherent story. It is something which appears most logical. It is rational. So the discovery of life on Mars to people studying the origin of life will be the greatest thing. As a matter of fact, in my mind, the search for extraterrestrial life is only part of the question of the study of the origin of life. This is the scientifically broader question, origin of life in the universe. And going to Mars is a unique opportunity that we have, perhaps the one only opportunity that we have of showing this, because there's life on Mars, and especially if we can show that its origin was different from the origin of life on Earth, or it was independent, then we'll have a very heartening answer to this question of uniqueness in life.
New York Times science editor Walter Sullivan, author of the book on which this program is based, raised this question with Nobel Prize-winning chemist Dr. Harold Urey.
Dr. Urey, a lot of the discussion on the origin of life boils down to the question of whether there are other worlds, other solar systems. You believe there are.
It is my belief that if you have conditions such as we have on the Earth, life will spontaneously appear. I don't know how long it takes, maybe a million years, maybe a billion years, but sometime life as we know it will appear. Every indication is that the properties of the elements in the most distant stars that we look at are the same as those that we have on Earth. The physical universe is the same everywhere. That is our conclusion. The laws are the same as far as we go, as we understand them. And this, of course, means that the chemistry of carbon, nitrogen, oxygen, hydrogen, the four abundant elements in living things, the chemical properties of these elements will be the same wherever we are in the universe. And therefore we expect that they will have the capacity to evolve into what we would call living organisms, no matter where we go. Now, we don't expect that they will be the same,
Dr. Philip Morrison is professor of physics at the Massachusetts Institute of Technology.
The evolution of a complex being, certainly of man, and of any other vertebrate, say, is a very chancy thing. You can show that there were many, many choices that had to be made just to choose this enzyme rather than that. And if it hadn't been that way, the whole thing gone completely differently. So from their point of view, you look at the place you've come to and you say, well, it was impossible to get here. And they say, therefore, it will never happen again in the same way. That's the general view. On the other hand, if you look at the I think that's right. But if you look at the results, it's quite different. If I go down to the museum across the park here, I can see very beautiful skeletons, impressions, fossil impressions, and even impressions of the fleshy parts in the soft stone from a beast. I've forgotten his
plesiosaur.
Plesiosaur?
Yes.
I'm suspicious about that, but you claim that's right. All right. Who is really a reptile and was extinct some hundreds of millions of years, but who swam in the oceans in a pelagic way as a marine reptile. And he looks for all the world like a large torpedo-shaped object about 8 or 10 feet long. Now then, you look at a tuna, big tuna. He looks very similar. It's not at all a reptile, but a fish. Quite a different and really a rather more primitive object. And finally, you may look at a dolphin, was a mammal whose ancestors were land mammals, air-breathing fellows like ourselves, who himself still breathes every 2 or 3 minutes, comes up. But all of these beasts were beautifully adapted by selection, by many, many, many generations of careful selection on all kinds of genes, to be able to swim very well and make a living in the scale of 8 to 10 feet long by catching fast fish in the sea. There are many, many paths to get to Central Park, but when you get there, you've arrived at the same place. If you look at any path that you've taken, every turn, every street light, you certainly can't predict when I start out exactly how I'll go, but I'm pretty well sure what the end is going to be, because that end is a satisfactory one, and I persist when I'm there. If there's any chance for a form to evolve on the surface of the planet, a very complex, rich form of life, it's going to happen.
Now, if this is true, if it seems reasonable to suppose that there's intelligence on many other planets, what do these fellows look like?
I don't know very well. I think that more like us than one might believe, but less like us than the common run of what we would regard as human. Right. Something in between. In other words, I don't think there'll be 50-foot skeletal figures with long, with long, wiry arms. I don't think there'll be round spheres 4 inches in diameter. And that's
simply for evolutionary reasons.
Simply for evolutionary reasons. You've got to have a certain size, not too big, not too small. You've got to be big enough to have this complicated machinery in it. Can't be too small. Can't be too big, or it's very hard to manage on a planet that of anything like the chemical composition we're talking about. And but as to inconsequential things, I don't know. Now, some people go far. Some people say yes. You see, the number of fingers will not be 5. I think it'll be something like fingers. But I would be willing to believe there might be 4, there might be 8, there might even be 16. But I don't think there'll be 500. I don't think there'll be 1.
We are not alone. We'll continue with the story of the race for planetary exploration and the UFO controversy after this message from the B.F. Goodrich Company.
Meet Jeffrey Masters, nuclear physicist. When it comes to splitting atoms, nothing stumps Jeffrey. But when it comes to buying tires, everything does. Jeffrey is snowed by tire talk. Cross-brace treads, 4-ply rayon, 2nd line, 3rd line, 4th line. And faced with tire sizes and tire prices, he draws a blank. So Jeffrey has been sold some pretty peculiar tires. Jeffrey, you know there's got to be an easier way to buy tires. Come on over to B.F. Goodrich. We've got a brand new way of doing business. We call it straight talk. We know you don't know a lot of technical tire talk, but you know a lot about how you drive, right? Okay, take this, our B.F. Goodrich Tire Value Calculator. Go on, work it yourself. Tell it how you draw it. Now turn it over. It tells you what kind of B.F. Goodrich tire is best for you. You don't have to be confused anymore. You see just what you're getting, just what you're paying for. Jeffrey, what do you think of B.F. Goodrich Straight Talk?
Empirically speaking, I explicitly endorse your methodology.
Thanks a lot, Jeff. Tell your friends, B.F. Goodrich, the Straight Talk Tire People.
Here again, ABC News correspondent Edward P. Morgan.
Sometime in 1973, a spacecraft will take off from Earth. Its name will be Voyager. The Voyager, a new kind of space vehicle, will begin a trek to the planet Mars. The first of a series of missions that will eventually carry sophisticated life detection devices to the Martian surface. The success of a Voyager mission would be a scientific breakthrough in our unmanned planetary program. It will be our first attempt to soft land an instrument package on another planet. Looking beyond Voyager to 1977, 1979, and the 1980s, space engineers are already at the hard, practical model stage of designing devices that are still emerging from the minds of scientific dreamers. One such device, designed for a Mars life search, is the Automated Biological Laboratory called an ABL. One concept of it has been developed by the Aeroneutronic Division of the Philco Corporation. It would operate remotely and automatically on Mars, so says space research engineer William Hostetler.
But basically, there are several processes that have to be performed. First, of course, you have to obtain physical samples of the surface of Mars, physical samples of the soil, because that's where the organisms will congregate if there are living organisms. I might comment, incidentally, that we are concerned more with the lower forms of life, the molecular forms of life, rather than elephants and horses and so forth. We are prepared to take pictures of these things if they happen to be there. The ABL is divided really into three basic integrated subsystems. One of these is the sampling subsystem that is used to obtain the surface samples from the soil samples from the surface of Mars. At the very bottom of the ABL and directly underneath, there is a system that uses a brush and vacuum system to obtain samples of the Martian surface directly under the ABL. Also, there is a core drill system that drills into the surface about 10 feet to obtain subsurface samples in case the water availability or other conditions make it more likely as a place for Martian biological life. A second system picks up samples around the ABL with a sampler, as you see here, which is located on a linkage that attaches it to the main body and will pick up samples from generally around the ABL location. A third system is used for getting samples from a considerably further distance, and in particular selected areas that the visual survey system has pointed out as being particularly desirable because possibly they are warmer than the surrounding spots, or they have a different appearance that might appear to be vegetation or something of that nature. So a sampling line is deployed ballistically, fired out like a small rocket, carrying this line to some distance, up to possibly 1,000 feet from the ABL location. And a sampler, then, similar to the one that works in the vicinity of the ABL, is carried up on an elevator, latched onto a trolley on this line, and deployed out to the desired spot to obtain the surface sample, returning and delivering it to the operating parts of the ABL. These samples are then processed and brought into the interior of the ABL for chemical processing prior to reading out the experiment. The chemical processing equipment is located generally in the central area of the ABL in the form of 13 chemical processors located circumferentially around the central core.
certain supplies, water, certain gases, are stored in tanks around the center of the ABL. Other chemical reagents are stored in ampules, which hold individual quantities in this area that surrounds the processors. These ampules are put into cartridges like this so that they feed to the outer end and can be picked up by the transport device, which internally then moves them to the proper location to conduct the chemical analysis. After the analysis is completed, the samples are then transferred to the instruments to read out the experiment results. The data from these are then processed internally and transmitted through the high-gain system back to Earth.
If the scientific and engineering problems that must be solved to accomplish this feat are not overwhelming, the political obstacles may indeed be insurmountable. Congress will soon have to make the most important decision on space policy since President Kennedy first won approval to commit us to the space age. The future of planetary exploration will hinge on the outcome of congressional action that will begin with hearings now set for February 1967. Because of the need for long lead times, planning policy and funds must be committed now, not only for the Voyager program in 1973, but for the life detection missions to Mars and Venus to come in the next decade or two. Whether the Soviet Union has its equivalent of our Voyager ready to shoot for Mars or Venus is no longer in question. In Russia, cosmic expositions and public displays of space vehicles are commonplace. Interest in planetary exploration and the search for extraterrestrial life is at a high pitch among scientists and the public alike. If our race for space with the Soviet Union were to be judged by who will first land a man on the moon, the contest at this stage might be considered a dead heat. But if the second lap of this race is one of planetary discovery on which depends the exciting scientific trophies of the foreseeable future, then the United States is estimated far behind. Soviet cosmonauts, male and female, become the honored protégés of the state, symbols of Soviet communist achievement. Not so burdened by war costs, the Soviet budget, according to a recent analysis, has allocated to planetary exploration from 5 to 10 times as much as the United States. And as a result, the great discoveries concerning our neighboring planets, Mars and Venus, will be made by the Russians unless early steps are taken to escalate the American effort. In the field of radio astronomy, too, the Soviets had been more consistently searching for extraterrestrial signals and recently reported having observed beacons of an interstellar civilization. Although later observations by American scientists negated their claims, the Russians never completely revised their earlier contention. However, in the area of the extraterrestrial life search, they have held the door open to international cooperation, says astronomer Carl Sagan.
They have made a recommendation that a worldwide international cooperation be established for a thoroughgoing search of large numbers of stars and galaxies to see if there is any intelligible radio communication being sent. And who knows, it's possible that such a collaborative effort might be established. Previous collaborative efforts, for example, the IGY between the United States, the Soviet Union, and other countries have been enormously productive scientifically and, in fact, in other ways.
A persistent furor in the past few years is the one over the alleged sightings of flying saucers. The number of officially reported sightings of UFOs, unidentified flying objects, has risen from 399 in 1963 to more than 1,500 in the last 18 months, according to U.S. Air Force figures. A cult of enthusiasts has developed, promoting the theory that these phenomena are visitations from intelligent beings in outer space, And according to a recent Gallup poll, about 5 million people have reported seeing UFOs over the years. Organizations with names like Flying Saucer News Club of America and National Investigations Committee on Aerial Phenomena, which has doubled its membership of 5,000 in the last year and a half, have sprung up, complete with annual conventions, recruiting drives, and publicity bulletins arguing for acceptance of the idea that flying saucers must be dealt with as emissaries, far-out diplomats from space. The scientific community, even those scientists committed to the belief that other intelligent life does exist somewhere in the cosmos, has greeted the flying saucer theory in the main with open skepticism. Physicist Dr. Philip Morrison of Massachusetts Institute of Technology.
The social phenomenon, the phenomenon of journalism and television. If you look in the records of newspapers of 100 to 120 years ago, exactly the same things were seen, exactly the same stories were given. They're much more frequent now. And what has happened is this infernal invention of the phrase, the flying saucer. However, most of the things they see are, as we all well know, planets and lights in the sky and aircraft and so on. And I think it's one of the most striking evidences, if I may exploit this opportunity, that we don't really have a deep spread understanding and education in science is the fact that people are not able to cope with the phenomena they see in any other way but inventing what I agree is a possible theory, but a very much more improbable theory than most of the things that describe the fact. And I think there's a sneaking suspicion also in the literature of the flying saucer that this is just some terrestrial object of secret kind, which is surely another social phenomenon in response to the enormous importance given to secrecy and military preparations in secret, which is the characteristic feature of the last 20 or 30 years. And if you take these two things out of it, then you don't have a great deal left, except a lot of interesting phenomena seen by people, some of which are new and quite unexplained, and would be nice to find out more about, but a great many of which are rather familiar things seen under unfamiliar circumstances.
We are not alone. We'll continue with the religious and philosophical implications that would result from the discovery of life on other worlds after this message from the B.F. Goodrich Company.
How come the typical American motorist puts off buying tires until he can't put it off any longer? Maybe it's because the typical American tire store is like a foreign country. A whole new world with a strange and different language. When you ask for help, you need an interpreter to help you with the answers. And when you finally get the bill, now you don't have to let tire buying get you down. Go see B.F. Goodrich. At B.F. Goodrich, we speak your language. Straight talk. If you don't understand that four-ply first-line miracle tread business, try this. The B.F. Goodrich Tire Value Calculator. It takes the confusion out of tire buying. You feed it the facts about how you drive. Then spin the dial. And it comes up with the right B.F. Goodrich tire, the lowest price tire for your driving needs. Straight talk. How about it, typical American motorists? Ready for a little straight talk? B.F. Goodrich. The straight talk tire people.
What if, one day, we do actually establish radio communication with some other civilization out in the cosmos? The possibility cannot be dismissed. The prospect has captured the imaginations and stirred the emotions of scientists and laymen alike. One of the stunning questions raised by the possibility of life on other planets, in other solar systems, is this. If proved, what will it do to theology? Man has been inclined to conceive of himself as cast in an earthly but divine image of God or gods. What if God supervised the beginnings of other civilizations on other planets first? Do the Martians, if any, have their equivalent of Adam and Eve? Did somebody else out there discover, long before Darwin, the Darwinian theory of evolution? These and countless other related religious questions, of course, must await the results of these new Christopher Columbus voyages of science through the solar system.
Dr. Morrison, for centuries, and really ever since man evolved on this planet, he thought of himself as being central, as being unique, as being the supreme representation of life. Supposing we discover that this is not the case, we know we're not central, suppose we discover we're also not really as superior as other beings elsewhere. What is going to be the effect of this on our concept of our place in the universe and of ourselves? And
everyone who tries to think of himself as having a view of the world and seeing his place in it, whatever his attitudes, will agree, I think, that above all, you have to be true. You'd like to find out if it turns out we have to adjust to this, certainly we can do so. I think it will in some ways remove what must be an essential loneliness of this position, and an arrogance, a sense of responsibility, which perhaps is not all ours. Is it not true that, at least in the Western world, in the Atlantic community, and as far as the Ural Mountains, Europe and North America, there has been a lengthy tradition of saying that all that is most valuable in the view of life, a view of the state, a view of the individual, a view of morality, a great deal of that comes, of course, from our religious development. But an equally large, or an almost equally large contribution comes from the study of societies which are absolutely gone, with whom we never again communicate. The most important being the world of Greece. The Greek playwrights, the Greek philosophers, the Greek historians and statesmen their thought and what they did is on the lips and on the pens of most of the learned people in the world. All we have is contained in about 10 or 15,000 books, which is a small library easily held in a good-sized office. Those are all the Greek texts about everything that we will ever have. And yet scholars and students have gone over and over and over those, and they're terribly valuable. Now we've extended that in our time, because most by studying other cultures with their rich traditions, the culture of the Orient, the cultures of America, old America, the cultures of West Africa, and so on, each of which have big contributions and give us a lot of understanding, a lot of insight. And I don't think we make a real human culture until we have all of this fed in. And I think on top of that, enriching it by having a story equally complex and much longer, but in less detail, which was the kind of thing we'd have to have from some remote society, could do anything but add a tremendous challenge and enrichment and satisfaction to those people. Indeed, I think, if I put myself into their place, that's the reason they would do it. Because then it would be added to their libraries, too, what our history has been. And that must be the only thing they can't guess from science, is the complexity of playwriting or the histories of kings or folklore. You can get their general pattern, but the detail is too rich. You can easily show mathematically. There's just too many possibilities. So I think that they will also be happy to have one more library coming into their signals, and that's what I'd like to say.
Mr. Walter Sullivan.
What a wonderful planet is our world, and how far it may be to anything else like it. We have reason to believe there are other planets blessed with our advantages, a kindly, stable parent star, a well-placed orbit, a suitable atmosphere, dry continents for advanced life forms, great seas within which their primitive ancestors evolved. But the fragile green hue of life appears only here and there on our planet as seen from space. Its hold is tenuous. If inbred passions overcome reason, we can now render the planet uninhabitable. Is that the fate of all technological societies? It is up to us on this wonderful world of ours to prove that it is not so.
Not Alone has been brought to you by B.F. Goodrich, the name that spells quality in tires, chemicals, plastics, footwear, products for home, industry, and aviation. B.F. Goodrich. This has been a presentation of ABC News.